The diagram shows a small block B of mass 0.4 kilograms and a particle P of mass 0.6 kilogram, which are attached to the ends of a light inextensible string. The string is taut and passes over a small pulley fixed at the intersection of the horizontal surface and the inclined plane. The block can move over the horizontal surface, which is rough, and the particle can move on the inclined plane, which is smooth, and makes an angle theta, where tan theta is 12/5. The system is released from rest, and in the first 0.5 seconds of the motion, P moves 0.4 meters down the plane, and B does not reach the pulley. Find the tension in the string during the first 0.5 seconds of motion, and calculate the coefficient of friction between B and the horizontal surface. Okay, like with all mechanics problems, the first step would be to draw a diagram. So taking the diagram and then putting all the forces. So remembering this one's rough, this one is a smooth plane, rough horizontal surface. So we have the tension acting here on B. We have its weight, 0.4 G newtons. We have a normal reaction RB. And because this is rough, there will be a friction which will be equal to mu times the RB. So, on this block we have a weight of 0.6 G newtons. We have the same tension as this one, but acting up the rope here, and we have a normal reaction RP. We also can split this weight into two components, this one acting downwards here, and this one acting parallel to the plane here. We have an acceleration, which we're going to need to calculate. So, and we know that tan theta is 12/5. So if we draw a right-angled triangle where this is 12 because it's opposite and this is 5, then this by Pythagoras will be 13. And then we can write down that sine theta will be 12/13 and cos theta is equal to 5/13. And every time we need to use sine or cos theta in our question, we can just replace it with those values. So, the time taken is 0.5 seconds. The initial velocity is 0 because it goes from rest. S is going to be 0.4 meters, and we need to use that to calculate the acceleration. So using S is equal to ut plus a half at squared. So we're trying to find the acceleration in the first 0.5 seconds of motion. We're going to have that 0.4, which is the displacement, is 0 times 0.5, which we could miss out if we wanted to, plus a half times A, what we want to calculate, times 0.5 squared. Rearranging that, we're going to get that A is 2 times 0.4 over 0.5 squared, which will give me 3.2 meters per second squared. Right, if we now consider the particle P, to find the tension. Now there's no force acting this way, so the only force acting down this way is going to be this component of its weight, which is going to be 0.6 sine of the angle here, which is theta. So 0.6 times sine theta, which is 12/13, minus t is equal to 0.6 times 3.2. And then rearranging for t, we're going to get that t is 0.6 g times 12/13 minus 0.6 times 3.2. Basically, we're taking that over there and that over here. Using the fraction button on our calculator, 9.8 for g, we're going to have that being 3.51 newtons. Now, more useful for the second part of the question is as a fraction, and you get that on your calculator using the S to D button, 228/65 newtons. We could write that down as our answer at this stage, but in future calculations, we can put that in, and that avoids making a rounding error. Right, just redrawing out the diagram, but we can now mark on that A is 3.2 meters per second squared. And now we're going to consider this block here. If we resolve this way first, because we want to find our RB, the normal reaction of B when it's on the horizontal plane. So resolving vertically, so we're going to get the RB minus 0.4 G is going to be equal to 0 because it doesn't move anywhere in this direction. And that gives that RB is 0.4 G newtons. And then resolving along the plane, we're going to have that T minus mu RB is going to be equal to mass times acceleration using Newton's second law. So we have the tension from the first part, but use the one that is a fraction, minus mu times RB, which we have up here, which is 0.4 G, is going to be equal to 0.4 times our acceleration, which is 3.2. Rearranging for mu, we're going to have 228 over 65 minus 0.4 times 3.2, all divided by 0.4 G, which give an answer of 0.56823 significant figures. Okay, so this has been a video to show you how to find the tension in a system and then use that to find the coefficient of friction. I hope you've understood, and I thank you very much for watching.